power factor in an LCR circuit, the apparent power and the phase angle. So let me explain what this phase angle is. Suppose if you apply an EMF E equal to E naught sine omega t across an inductor, capacitor, resistor, or either only inductor and resistor, or capacitor and resistor, or all three, or anything. So the current will be equal to I naught sine, if it is only resistor, I naught sine omega t. If it is only capacitor, omega t plus pi by 2. Only inductor, it is minus pi by 2. When it is a mix of any two or all three, it will be equal to plus or minus phi. So this is the instantaneous voltage and then the instantaneous current. And if you want to find out the average of the power, so you'll be doing integral EI, which is power, into dt divided by integral dt over one full cycle, means 0 to t. This is very similar to the average of the current is integral current into dt by integral dt. So the average of the power is power into dt. So this is basically power, because power, instantaneous power, is equal to instantaneous EMF into instantaneous current, because we know that power is equal to VI. So instantaneous power is equal to E into I into dt. So the other things here you should know is from this learning, integral sine omega t dt by integral dt over full cycle 0 to t, we have found it to be 0. So basically integral of sine omega t dt or integral of cos omega t dt, or in general this one is known as average of sine omega t, or average of cos omega t, or average of sine 2 omega t, 3 omega t, or in general n omega t, or cos omega t. So cos of n omega t, all will be 0, because sine omega t, cos omega t will have waveform like this, and this positive area and the negative area, this positive area and the negative area are equal, hence they will always yield 0 value. That you should remember. So let us go on calculating the power. So the average power is equal to V into I into dt. So integral 0 to t, EMF applied is E naught sine omega t. Because of that, the current is I naught sine omega t. Let me take it as plus phi. You can take it as minus phi also. The answer will be the same. So whole divided by integral dt is t, 0 to t. So upper limit t minus 0, the whole value becomes t. So I am taking E naught and I naught out. E naught I naught by t integral 0 to t sine omega t into sine of omega t plus phi. So this sine of a plus b, so I can write it as sine a cos b plus cos a sine b into dt. So here E naught I naught by t integral 0 to t, when you multiply this with this, sine square omega t cos phi into dt plus integral, when you multiply this with this, sine omega t cos omega t sine phi into dt. So 0 to t. E naught I naught by t integral cos phi is a constant, I am taking out cos phi, integral 0 to t sine square omega t dt. Sine square omega t is 1 minus cos 2 omega t by 2 into dt. If you don't know this, in the previous value, like while we finding the RMS value of AC current, we did this formula. Kindly go and check it. Plus integral I am taking sine phi out, integral sine omega t cos omega t is there. I am just multiplying by 2 and dividing by 2. So that 2 will be here. 2 sine omega t cos omega t is sine 2 omega t dt. We know that over a full cycle sine 2 omega t is 0. So this whole term becomes 0. So E naught I naught by t into cos phi integral 1 by 2 into dt 0 to t minus 1 by 2 into integral cos 2 omega t dt 0 to t. We know that integral cos 2 omega t is also 0. So what we are getting here, A naught I naught by t cos phi, then I am taking half integral dt is t 0 to t, and I am having here what, E naught I naught by t cos phi into half into t. T and t will be cancelled. So the average power dissipated in an AC circuit is E naught I naught by 2 into cos phi, which can be written as 2 can be written as root 2 into root 2. So this 2 is E naught by root 2 and this is I naught by root 2 into cos phi. We know that E naught by root 2 is ERMS, I naught by root 2 is IRMS. So the average power dissipated in an AC circuit is ERMS, IRMS, RMS value of voltage, RMS value of current into cos phi. So blocking this, forget about this, ERMS, IRMS seems to be the power, because in the previous chapters we learned that power is equal to V into I. At best what we had expected here was power should have been VRMS into IRMS, but there is an additional thing that appears here which is cos phi. So this thing is termed as power factor, and ERMS IRMS seems to be the apparent power. So it seems to be the power but it is not, that is why it is called apparent power. And this is the average power dissipated or power dissipated in an AC circuit. So average power dissipated in an AC circuit, average power dissipated equal to apparent power into power factor. So, or in other words, you can define power factor cos phi as the average power dissipated to apparent power, ERMS, IRMS. So it is average power dissipated to apparent power. So the ratio of average power to apparent power dissipated in a circuit is called the power factor. This power factor from LCR circuit we already knew that if this is R and this is XL minus XC and this one is the impedance Z is equal to square root of R square plus XL minus XC the whole square. So the power factor can be found using this cos phi equal to adjacent side by hypotenuse side, R divided by square root of R square plus XL minus XC the whole square. Suppose the circuit is only resistor, then cos phi, the power factor is R divided by square root of R square plus 0 square, because only resistor, no XL, no XC. So this becomes R by R is equal to 1. So only inductor or capacitor, R is 0. So whether it is only inductor or only capacitor, R is 0. So 0 by anything is 0 by anything or 0 by the impedance equal to 0. In general, remember the power factor cos phi equal to R by Z. So power factor cos phi equal to R by Z or R by divided by this. Another thing, suppose if you are using a choke coil. Choke coil should be having only inductor, but the choke coil is made of N turns, it must be having some resistance R. So in the case of choke coil, power factor cos phi is equal to the resistance of the choke coil divided by square root of R square plus XL is there, but XC is 0 for a choke coil, which means the power factor for a choke coil is R divided by root of R square plus XL square. So we'll discuss further things in another video.